everyone, this is Madhura L from 3rd Sem Brahmo section. My USN is 1BE23EC052 from ECE. Today's subject is network analysis. Today's topic is mesh analysis. What is mesh analysis? Mesh analysis is defined as the method in which the current flowing through a planar circuit is calculated. A planar circuit is defined as the circuits that are drawn on the plane surface in which there are no wires crossing each other. Therefore, a mesh analysis can also be known as loop analysis or mesh current method. What is branch? A branch is defined as the path that connects two nodes such that it contains a circuit element. If the branch belongs to only one mesh, then the branch current and the mesh current will be equal to each other. Procedure to find the mesh analysis. The following steps are to be followed while solving the given electrical network using mesh analysis. Step 1. To identify the meshes and label these meshes currents in either clockwise or counterclockwise direction. Step 2. To observe the amount of current that flows through each element in terms of mesh current. Step 3. Writing the mesh equations to all meshes using Kirchhoff's voltage law and then Ohm's law. Step 4. The mesh currents are obtained by following step 3, in which the mesh equations are solved. Next, hence, for a given electrical circuit, the current flowing through any element and the voltage across any element can be determined using the node voltages. And this is the diagram for mesh current. The below diagram is a circuit with mesh currents labeled as I1, I2 and I3, and the arrows represent the direction of the mesh current. And the voltage is Vs, and inductor is known as L, and there are three resistors in it, that is R1, R2, R3, and the capacitor in the middle. What is super mesh analysis? Super mesh analysis is used for solving huge and complex circuits in which two meshes share a common component as a source of current. Example of mesh analysis. Example 1. In the given circuit, 90 volt is the battery value, 5 ampere is the current source, and the three resistors are 9 ohms, 6 ohms and 8 ohms. Using mesh analysis, determine the current across each resistor and potential difference. So, R1 is 9 ohm, R2 is 6 ohm and R3 is 8 ohm in this diagram of example 1. So, for the solution for the example 1, let's first determine the ground as shown in the figure. Let the potential be VA, VB and VC as shown in the figure. Let I1 and I2 be the currents flowing through the two loops in the clockwise direction as shown in the figure. And this is the diagram respectively. Therefore, VB minus V1 minus V2 is equal to 0. Then 90 minus I1 R1 minus R2 I1 minus I2 is equal to 0. 90 minus 9 I1 minus 6 I1 minus I2 is equal to 0. Next step, minus 15 I1 plus 6 I2 is equal to minus 90. So, 5 I1 minus 2 I2 is equal to 30. This is obtained by dividing the equation with minus 3. Substituting I2 as minus 5 since the direction of I2 is opposite to the actual direction of current. Therefore, I1 is equal to 4 ampere. So, through R1, 4 ampere current is flowing and through R3, 5 ampere current is flowing. Now, the potential difference at VA is equal to 90 volt. At VB, the potential difference is V2 is equal to I2 minus R2. Therefore, VB is equal to 54 volt. Find the current I current through 10 ohm resistor using mesh analysis, and this is example 2 for the mesh analysis. We first analyze the circuit as it is planar, we move forward with the mesh analysis. Next, we observe that the network has two meshes and then assign current I1 and I2 to the meshes respectively. And this is the diagram. As shown, 5 ohm, 5 ohm and 10 ohm resistors are used and 10 volt voltage is used, AC voltage is used. So let us look at the solution. Developing the KVL equation for the mesh 1. 10 minus 5 I1 minus 5 I1 minus I2 is equal to 0. Now 2 I1 minus I2 is equal to 2 minus 1. Developing the KVL equation for the mesh 2, minus 5 I2 minus I1 minus 10 I2 is equal to 0. 3 I2 minus I1 is equal to 0 minus 2. And this equation is for the second one, and the first one equation is for the first diagram respectively. Solving equation. By solving equation 1 and 2, 3 I2 is equal to I1 from equation 2. Putting values in 1. That is, from taking 2, we have to put it in equation 1. 6 I2 minus I2 is equal to 2. I2 is equal to 552, which is equal to 0.4 ampere. Therefore, 12 is equal to I. Now, I value, that is current value, is 0.4 ampere. And those were the two examples for mesh analysis. In conclusion, mesh analysis is a powerful tool for analyzing DC circuits. It involves dividing the circuit into meshes, assigning current variables to each mesh, writing KVL equations for each mesh, and solving them simultaneously to obtain the mesh currents. And as we all know that mesh analysis is also known as loop analysis. So, thank you everyone for watching my video, and please do like and subscribe and please do share it. Thank you.